Hello, 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 hello. Can you hear me? Yeah, can you hear me? Yeah. Hello, hello. Can you hear me? Yeah. Okay, okay. I'm so sorry. I'm so sorry. I thought we canceled today. Sorry, 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 sorry. I thought we canceled today. Okay. Please hold on. I prepared the. You can hear me? Yeah. No problem. Okay. Can you hear me? Yeah. Okay. I thought. I thought we canceled today. Okay, I prepared the past exam papers. Okay, past exam papers on the organic chemistry. Okay, we can go through that. Okay, past exam papers on the organic chemistry. Okay, okay, let me open. Okay, let me open. Okay, okay. Hold on. Okay. Okay. Uh, okay. Yeah. Okay, so this paper here, okay, which is one of the recent papers. Okay, so one of the recent papers for the A levels. Okay, so the organic hold on. Okay. Um okay. Yeah. Okay, so one of the recent papers, March 2025, organic A levels paper one. Okay, paper one multiple choice. Okay, for organic chemistry, starts from question 25. Okay, start from question 25. Okay, let me open. Um, okay, okay, question 25. Yeah, so I just keep going. Yeah, if anything, you just stop me. Okay, okay, yeah, okay, hold on. Okay, okay, start from question 26. Okay, let's take a look. Okay, organic compound X has the empirical formula C2H4O. Okay, compound X is reduced by lithium aluminum hydride, but not sodium borohydride. Okay, so it can be reduced by lithium aluminum hydride, but not by sodium borohydride. Okay, so yeah, so I will show all the notes, okay, related to this question. So if I'm like saying too long-winded, you just stop me, okay? Okay, let me show the notes. Eh, okay, okay, so this one. Yeah, okay. So this one. So we can see what are the compounds that can be reduced by sodium borohydride. Okay, so sodium borohydride is a weaker reducing agent, so it can reduce carbonyl compounds only. Okay, so ketone to secondary alcohol and aldehyde to primary alcohol. Okay, so can reduce um, carbonyl compounds only. So lithium aluminum hydride, it is a stronger reducing agent. So it can reduce carbonyl compounds and also carboxylic acid. Okay. Yeah. And ester and nitriles. Okay. Everything. Okay. So including both carbonyl and carboxylic acid. So lithium aluminum hydride. Okay. So you see, this one Okay, compound X is reduced by lithium aluminum hydride, but not sodium borohydride. So means it is not carbonyl. Okay, it's not carbonyl because carbonyl can be reduced by sodium borohydride. So it's not carbonyl. So not aldehyde, not ketone. Okay, so ethanol is not included. Okay, so and alcohol, no, because alcohol it cannot be reduced further. Okay, cannot reduce further. Okay, so you see here, we reduce until alcohol stop. Okay, reduce until alcohol um already stop. Okay, so alcohol cannot be reduced further. Okay, so now we have ethanoic acid and butanoic acid. Okay, so they both fulfill this one. Okay, it can be reduced by a strong reducing agent, but cannot reduce by a weak reducing agent. Okay, so acid, it can be reduced by lithium aluminum hydride only. Okay, so now which one? So now we will check this. Okay, empirical formula. So this one, ethanoic acid. Okay, so it will be like this. So there should be two oxygen. Okay, but here, one oxygen only. So we know that this is not the one. Okay, how about butanoic acid? We can check. So this is empirical formula. If we times 2, we will get C4H8O2. Okay, so we can check butanoic acid. 1, 2, 3, 4. COOH. Okay, so carbon 1, 2, 3, 4. Okay, hydrogen 1, 2, 3, 4, 5, 6, 7, 8. Okay, H8O2. Okay, so it is matching. So the answer is D. Okay. Yeah. Anything you just stop me. Okay. Yeah. Yeah. If I can't hear it, you just louder. So I'm not sure I can hear or not. Okay. If I'm too long-winded, you just stop me. Okay. Okay. Mechanism of the reaction of hydrogen cyanide with propanone. Okay. Hydrogen cyanide with propanone. So propanone is this one. Yeah. Okay. So hydrogen cyanide with propanone is this one. Okay. Nucleophilic addition. Yeah. Okay. So nucleophilic addition. Why we can have nucleophilic addition? Because the carbonyl group. Okay. So the carbonyl group, we can see the CO. Okay. So carbonyl group for ketone or aldehyde. Either one, because of the more electronegative oxygen, we have delta positive here, delta negative here. So we have a positive center that can attract nucleophile. Yeah, okay. So anything with a lone pair to attack the delta positive center. So we are adding something. So this is nucleophilic reaction, but it's not substitution. We are not substituting something. We are adding something. So this is nucleophilic substitution. Okay, nucleophilic substitution. So this cyanide adding to the propanone. Okay, yeah. So something like that. Okay, propanone, and then this one delta positive. Okay, so delta positive, the hydrogen cyanide, okay, is like this. The cyanide, okay, negative, okay, can attack the delta positive here. Okay, so it is nucleophilic addition. Okay, next. Okay, which compound may be synthesized from alkene with a formula C4H8 by addition reaction? Yeah, okay. 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 Alkene, 4 carbon alkene. Okay. 1, 2, 3, 4, and then like this. Okay. So Okay, 1,1-dibromobutane. Okay, 1, 2, 3, 4. Okay, and then like this. So cannot. Okay, so addition will be either like this. Okay, must be on a different carbon. It cannot be on the same carbon. Okay, so another possible option will be like this. Okay, so we add like this. Okay, so this is another possible answer. Okay, but this one cannot. It cannot add to the same carbon. Okay, so this electrophilic um addition. Okay, it cannot add to the same carbon. Okay, 1,2-dibromobutane, which is this one. Okay, 1,2-dibromobutane. So this is correct. We can get it. Okay, 1,3-dibromobutane cannot. We cannot add 1,3 like that. Cannot, because we must add 1,2 or 2,3. Okay, so this one cannot. Okay, 1,3-dibromometal propane. Okay, so we can check this. Okay, so this one is, okay, we can have another option, which is like this. Okay, 1, 2, 3, 4, like this. Okay, so if we were to add the bromine, it will be like this. Okay, so like this. So let's try to sketch this one. See whether it match or not. Okay, propene, metal, and then 1, 3. Okay, so it's like this. Okay, so this one also does not match. Okay, so this one is 1, 2 1, 2, 2 dibromo, and then metal at the second carbon. Okay, so we should get something like this. Okay, but not this one. You cannot add carbon 1 and carbon 3. Must be carbon 1 and 2. So this one also incorrect. So the correct answer is B. Okay. Okay, next, structure of compound G. Okay, it undergoes addition polymerization, which diagram show the repeat unit of the polymer found. Okay, so yeah, so where it happened, the polymerization, where it happened. Okay, so it's not here. Okay, because oxygen already formed 2 bonds, it cannot form more bonds. Okay, so it cannot form the polymer chain, so it's not here. And then this one, okay, also cannot. Okay, the nitrogen, it already formed 2 bonds, it cannot form the polymer chain anymore. Okay, so this part. Okay, so always happen at the CC double bond. Okay, so it always happen at the CC double bond. So this will be the center of our chain. So our chain will be look like this. Okay, the repeat unit, and then like this. Okay, yep, and then the CN here. Okay, and like this. Okay, so always happen at the CC double bond. Okay, so polymerization always happen at the CC double bond. Okay, yep. Okay, so which one match this situation? Okay, so this one is incorrect. The double bond is not there anymore. So this one also no. Okay, so this one also no. Okay, so this is the correct answer. Okay, yeah. So always happen at the CC double bond. Okay. Next. Okay. Compound T is tested with 3 reagents and gives the result shown. Okay. 2D 2DNPH. Okay. 2-DNPH, if you recall, is a test for carbonyl. Yeah, okay. So it's a test for carbonyl. Okay, let's quickly look at the notes. Okay. Okay, 2-DNPH. Yeah, this one. Okay. 2-DNPH. Um, yes. Okay. So it's a good test for presence of carbonyl compound. So whether you have ketone or aldehyde, okay, either one, you can use this 2,4-DNPH to test it. Okay. If you put this 2,4-DNPH, it turns to this orange precipitate. Okay. Orange precipitate means you either have aldehyde or ketone. Okay. So means we have aldehyde, okay, or ketone. Okay. So okay, so first we can eliminate this one because this is alcohol. Okay, so this one no aldehyde or no ketone. Okay. Um okay, this one is ketone. Okay, so here this is the ketone group. And then this is the ketone group here. This is the alcohol. Okay. Alcohol plus ketone. Okay. And then this one is we have this aldehyde group here. Aldehyde. Okay, aldehyde group here. Okay. Failing solution, no reaction. Okay. Okay. Failing solution is a test for aldehyde. Yeah. Okay. It's a test for aldehyde. So no reaction means no aldehyde. Okay. No aldehyde. Okay. So let's check the failing. Yeah. Okay. This one. Okay. Failing solution. Okay. Yep. So this is a test for only by aldehyde. Yeah, only by aldehyde. Okay. So for the test for aldehyde, we have two. Okay. Failing solution, red precipitate, tolerance reagent, silver mirror. Okay. It's for aldehyde only. So we can use this test to differentiate between aldehyde and ketones. Yeah. Okay. So means no aldehyde. Acidified dichromate, no reaction. Okay. So this one is oxidation. Okay, oxidation. So this one we already eliminate because we say no aldehyde. Okay, this one already eliminate. Okay, so this one oxidation, no reaction. So means cannot be oxidized. Okay, cannot be oxidized. Okay, so what is the thing that cannot be oxidized? Ketone. Okay, ketone, it cannot be oxidized further. Okay, cannot oxidize further. Okay, so you can go from secondary alcohol. Yeah, secondary alcohol to ketone. We can oxidize, but ketone cannot oxidize any further. Okay, just stop here. Okay, so this one cannot be oxidized. So ketone cannot be oxidized. How about alcohol? Alcohol can be oxidized. Okay, so what kind of alcohol is this? 1, 2, 3, 4. Okay, 1, 2, 3, 4. Okay. Okay, alcohol is here. Okay, and then the ketone group is here. Okay, so this is a secondary alcohol. Secondary alcohol can be oxidized to ketone. Yeah, okay. So this one, it can be oxidized. Okay, so it's not this one. Okay, because we are saying that this one, no oxidation. Okay, so this one also no. So our answer is D. Okay, so our answer is D. Orange precipitate means it's a ketone. Failing solution, no reaction means not aldehyde. Okay, acidified chromate, no reaction means no oxidation. Okay, No oxidation, it is a ketone. Ketone cannot oxidize further. Okay, next. Okay. Reagent X added separately to this one. 2-methyl butane 1O and 3-methyl butane 2O. Yeah. The visible results are different. Okay. What is the reagent? Okay. So now let's sketch. Okay. Butane 1O. Okay. Butane 1O. 1, 2, 3, 4. Okay. Butane 1O. 1, 2, 3, 4. Okay. Okay, butane 1O and then two metal like this. Okay, metal group here. Okay. And then 3-methyl butane 2O. Okay, 1, 2, 3, 4. Okay. Okay, OH here and then metal group here. Okay. So which reagent will give a different result? Okay. Sodium. Okay, sodium, it will give same result. Okay, because alcohol can react with sodium. Okay, alcohol can react with sodium. Okay, let's take a look. Okay, yeah, anything you just stop me. Yeah? Okay. Okay, alcohol reaction with sodium. Mm, yes. Okay. Okay, what we are saying that okay, alcohol is weak acid. Okay, weak acid properties. Okay, properties. Okay, so if we look at carboxylic acid, okay, carboxylic acid compared to alcohol, it is a stronger acid. Okay, it is a stronger acid, so it can react with both sodium metal and it can react with um sodium hydroxide. Yeah, okay. So it can react with both sodium metal and sodium hydroxide both. Okay. Alcohol is considering weak acid properties. Okay. So it's not easy for it to lose the proton. Weak. Okay. So it can react with sodium metal only. Okay. Only. Okay. Sodium hydroxide cannot. Okay, sodium hydroxide cannot because sodium metal is a powerful, okay, it's a powerful proton acceptor. Okay, so it's a powerful proton acceptor. Okay, so it's a powerful reducing agent. Okay, so this is one way we can differentiate between alcohol and carboxylic acid. Okay, so carboxylic acid can react with both sodium metal and sodium hydroxide, but alcohol, sodium metal only. Okay, so reaction of alcohol with sodium metal is this. Okay, so it will form sodium alkoxide. Okay, and the hydrogen gas. Okay, so it can react with the sodium metal. Okay, so this coming back to our question, so we will get same result. Okay, but we want different result. Okay, we want different result. So this is no. Okay. Okay, acidified potassium manganate. Okay, acidified potassium manganate. What is this reaction for? Okay, so what is this reaction for? So it's useful to refer to this. Yeah, okay. The summary table is useful to refer. Potassium manganate. When we use the potassium manganate. Here. Okay. Potassium manganate, we use, okay, A6 and A7. Okay. We only use at these two situations, A6 and A7. Let's see what we are doing here. Okay. A6 and A7. A6, A7. Okay. Potassium manganate is to add two alcohol group to the alkene. Okay, when we want to add two alcohol group to the alkene, we use the potassium manganate, or when we use the hot potassium manganate. Okay, when we use the concentrated potassium manganate with heat with sulfuric acid. When we have this combination, we break up the alkene. Yeah, we break up the alkene to form things like carboxylic acid or carbon dioxide. Okay, something like that. So we used to break up the alkene. So no. Okay. So in this case, no reaction. Okay. No reaction for both. Okay. Potassium manganate does not react with the alcohol group. No reaction for both. So this is also no. Okay. PCl5. Okay. PCl5. When we use PCl5. Okay. Let's take a quick look. Okay. PCl5 is to um uh hold on. It's nucleophilic substitution. Yeah, okay. Nucleophilic substitution. Let me find a hold on. Yes, here. Okay. So alcohol react with PCl5, it will substitute the alcohol group to the halogen, okay, to the chloride, for example, okay. Substitute alcohol group to chloride, okay. So this one, both will give the same result, okay. Both will give the same result, okay. So what is our observation? Our observation is fizzing. Yeah, we will observe fizzing. Hydrogen chloride is evolved. Yeah, okay. Production of misty film. So this one, we expect both. Okay, misty films. Okay, so both. So we have the same observation. Same observation. Okay, so this is also no. Okay. Okay, how about alkaline I2? Okay, what is alkaline I2? Okay, alkaline I2 is to test for this part. Okay, yeah, this one. Triiodomethane. Okay, okay, alkaline I2. Test for this group here. Yeah. So whenever we have this group, okay, like this. Okay, carbon. Okay, so we have hydrogen joined to OH, H, and CH3 at the same time. Yeah, okay. So we can see here this carbon is joined to hydrogen, OH, and CH3 at the same time. If we put this alkaline I2, what will happen? It will turn to this ketone. Yeah, so uh, what we call methyl ketone. This methyl ketone will react with this, okay, alkaline iodine to form this, okay, which is the pale yellow. Yeah, okay, the pale yellow precipitate. Okay, so which means if we have this situation and this situation, we will get the pale yellow precipitate. Okay, yeah. Um, yep. Okay, so mostly specific tests for the this group here and this group here, methyl ketone. So either we have this one or this one, it will be active for this triiodo methane test. Okay. So now coming back to our question. Okay, so we can see here, this one, it actually has the triiodomethane group. Yeah, okay. So if we look at this carbon here, this carbon here, okay, this carbon. Okay, so one side is the metal group, one side is the OH group, one side hydrogen group. Okay, so this is the group that is active for the alkaline I2. So this one we will be having pale yellow PPT. Hello, hello, hello. Yeah, sorry. I think just something happened. I don't know why. Okay, okay. Okay. Yeah,
Yeah,
yeah, yeah. My internet connection just disconnected. Okay,
okay.
so now should be okay, yeah?
Yeah.
Okay, now should be okay. Yeah. Hold on. Okay. Now it's okay, yeah? Yeah, let's continue. Okay, so for this one we'll get pale yellow PPT. So this one we don't have this, okay? This group here. So this one will be no reaction. Yeah, okay? No change, no reaction. So this one we will be having different result. Okay, we'll be having different results. So this is the answer here. Okay, yeah, so that's the idea. Okay, next. Okay, compound Y is hydrolyzed by warm aqueous silver nitrate to form a precipitate that is soluble in dilute aqueous ammonia. Okay, compound Y undergoes elimination reaction to form alkene. Okay, what is the skeletal formula of compound Y? Okay, so compound Y hydrolyzed by warm aqueous silver nitrate. Okay, warm aqueous silver nitrate. This is a test for what? Okay, so let's go back to our notes. This is a test for, okay, hold on. A, okay, yep. Hold on. Mm, okay, yeah, okay. Let's go back to our notes. Okay, so this is halogenal alkane. Uh, okay, okay, yep, okay. Wait. Yes, okay. So when we have the bromoalkane, okay, bromoalkane, we can react with this um aqueous silver nitrate. Okay, we can react with the aqueous silver nitrate, and then we can get the silver halide. Okay, we can get either aluminum chloride, aluminum bromide, or aluminum iodide. Yeah, okay. So we expect to get these three. Okay. So first step, we know that this compound Y, it must be halogenal alkane. Yeah, it must be halogenal alkane. But which one? Okay. Um, okay, soluble in dilute aqueous ammonia. So this is another clue here. Okay. So basically it will form this AgCl, AgBr, Ag, okay, iodide, and then we can check, okay, check solubility in ammonia, okay, check solubility in ammonia. Okay, so this is in another topic. Okay, let me open. Okay, okay, it's here. Yes, okay. So silver nitrate, okay, react with the bromoalkane, it will form this, okay, silver chloride, silver bromide, and silver iodide. Okay, and then the color white, pale yellow, or deep yellow, no problem. And then next, solubility in ammonia. Okay, so it's soluble in dilute ammonia, soluble in concentrated ammonia, insoluble in concentrated ammonia. Okay, so this is how we can differentiate the three. Okay, this is how we can differentiate these three apart from the color. Okay, apart from the color, another way we can differentiate. Okay, let's look at our question. Okay, our question say, soluble in dilute aqueous ammonia. Soluble in dilute aqueous ammonia, which telling us is this one. Okay, is this one. So it's a chloride. It's a chloride. So this one, no, this one, no. It's a chloride. Okay, our question is, which one? Okay, this one or this one? Okay, our answer is this one. Why? Because this one, it can undergo elimination. Okay, okay, elimination to form, okay, alkene, no problem. Okay, this one cannot elimination because this carbon, it got no hydrogen. Yeah, okay. For elimination, you must one side eliminate the hydrogen, one side eliminate the chloride. This one, this carbon, it has no hydrogen, so it cannot undergo elimination. So this is not the correct answer. So answer is C. Okay. Next. Okay. Propane 2O can be converted to 2-chloropropane using reagent M followed by reagent N. Okay. So it is a two-step process. Okay. Two-step process. Okay. Um, Okay, so what is the two-step process? Propane 2O, 1, 2, 3. Okay, like this. Okay, propane 2O. Okay, and then should be, okay, should be like this. Second step, elimination. Okay, okay, elimination. Okay, and then the next step will be electrophilic addition. Okay, electrophilic addition to like this. 2-chloropropane. Okay, like this. Okay, so what is the first step? Okay, alcohol to alkene elimination. So we can check our summary. Okay, alcohol to alkene. This one. Okay, alcohol to alkene elimination A2. Okay, reaction condition A2. Yes. Okay, aluminium oxide heat or um concentrated sulfuric acid plus heat. Okay, these two conditions. Okay, so okay, so we can see here concentrated sulfuric acid, no problem. Okay, actually another one, this one also can. This one also can. Um, let me show. Okay, here. Yeah, okay. So we can use concentrated sulfuric acid. This can be used. Okay, we can also use um aluminium oxide, okay, with heating. We can also use phosphoric acid with heating, okay. Concentrated phosphoric acid also can be used, okay. So which means this is also acceptable, okay. Phosphoric acid also acceptable. So this one will be no, okay. Yep, so that is the first step, okay. And then second step, electrophilic addition, okay. So electrophilic addition of H and Cl, right? Electrophilic addition of H and Cl. Okay, let's check our summary from alkene to bromoalkene. Okay. Okay, so this one. Okay, alkene to bromoalkene. Yeah, this one. So it is A3. Okay, let's check here. Okay, HBr at room temperature. HBr at room temperature. So which means here we need to use HCl. Yeah, okay. So we need to use HCl. So our answer is C. Yep. Okay, our answer is C. Okay. Okay, next. Okay, skeletal formula of four organic compounds are shown. Which two compounds, when separately heated with dilute sulfuric acid, okay, dilute sulfuric acid, okay, produce propanoic acid as one of the products, okay, heated with dilute sulfuric acid. Okay, um, let's check. Okay, so coming back to our summary, okay, dilute sulfuric acid, when we use it, okay, when we use dilute sulfuric acid, um, okay, with heating. Okay, let's check. Yes, dilute sulfuric acid with heating, okay, is when we want to D3, D8, and D10. Okay, so let's check D3, D8, and D10. Okay, okay. This one. Okay. Is the hydrolysis. Okay. So basically, it's a hydrolysis um of the ester. Okay, hydrolysis of the ester. So we want to break down the ester. Okay, to get back the alcohol and the acid. Okay. So in which part we have the hydrolysis? Okay, a hydrolysis here. Okay, so this one, after we break it up, we get this. Okay, this is the propanoic acid. Okay, so if we break down the uh ester bond, okay, so this dilute sulfuric acid is for breaking down the ester bond. Okay, yeah. Let me just confirm. Okay. Yes. Okay, ester. Okay, reaction of esters. Okay, heat with, okay, aqueous sulfuric acid. We break the ester bond to get back the acid and alcohol. Okay, so this is a ester hydrolysis. Okay, we can also use the sodium hydroxide, heating with sodium hydroxide. Okay, in alkaline condition, we can get the acid and then we can get the alcohol, but the acid will react with the sodium hydroxide to form the salt. Okay, so that is the difference. Okay, so this uh aqueous sodium, I mean the aqueous sulfuric acid is for the hydrolysis. Okay, break down the ester bond. Okay, and yeah, so another one, this is another ester bond. Okay, and then this is the acid part, but this is ethanoic acid. Okay, this ethanoic acid. So 4 is no. Okay, 4 is no. So we eliminate this one, eliminate this one. Okay. Um, this one is aldehyde. Okay, this is aldehyde. If we want to get to propanoic acid, if we want to get to acid, actually we we need to do oxidation. Okay, oxidation, aldehyde to acid. Okay, let us confirm here. Okay, okay, so if we want to go from um aldehyde to acid, okay, D6, aldehyde to acid, D6, a hold on, wait. Yeah, D6 here. Okay, so we actually need this. Okay, dichromate. We need the oxidizing agent. Okay, we need the dichromate. So, dichromate. Okay, so dilute sulfuric acid cannot. We cannot use dilute sulfuric acid. So one cannot. Okay, so the answer is C. Okay, so we can confirm this one. CN from nitrile to acid. Okay, from nitrile to acid, how it works. Okay, so we can take a look. Okay, this is acid here. Okay, nitrile to acid. Nitrile to acid, D3. Okay. Hold on. Okay, nitrile to acid. So we can see here. Yeah, okay. Sulfuric acid with heat. Yeah, okay. Heating with sulfuric acid. So it's the same reaction condition. Okay. Yes. So this one also H2SO4 with heat. Okay. So it's the same condition. And then this one, it will turn to 1, 2, 3. Okay. It will turn to propanoic acid, which is what we want. Okay. So the answer is 2, 3. Okay. Next. Okay. This one. All right. Okay. So we have 1-chloro-2 metal propane. Okay. 1-chloro-2 metal propane is look like this. Okay. Propane. Okay. Uh, 1 chloro. Okay. 2 metal like this. Okay. And then the other one, butane. 1, 2, 3, 4. Okay. 2 bromo, 2 metal. Okay. Like this. Okay. React separately with aqueous silver nitrate in ethanol. Okay. So what is this condition for? Okay. React with um aqueous silver nitrate. Okay, let's check. A yes. Hold on. Okay, so this one just now the bromoalkane react with silver, we will get alcohol. Yeah, okay. We will substitute the halide to alcohol. Okay, so that is what happened. Okay, substitute the halide to alcohol. Okay, so this one we will turn to this. Okay, okay, turn to OH. Okay, and then this one, okay, so this one, it will turn to OH. Okay, so this is the effect of the reaction with the silver nitrate. Okay, but what kind of reaction is this? Okay, this is nucleophilic substitution. Okay, this is also nucleophilic substitution. Okay, yeah. Both reaction proceed by nucleophilic substitution and a precipitate is formed. Okay, so nucleophilic substitution, we have two types. We have SN1 and SN2. Okay, can remember? Can remember? So you see this one, okay, if we look at this carbon, okay, if we look at this carbon, once the bromine is gone, okay, this one is a tertiary carbon. Yeah, okay. Tertiary carbon, okay, will form tertiary carbocation. Okay, tertiary carbocation, which means it will go through the SN1. Okay, it is the SN1. This one, this carbon is a primary carbon. Yeah, okay. So primary carbon, so it will go through the SN2. Okay, So let me quickly explain again why. Okay. Yeah. Okay. You see this one. Um. Yeah. 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 Okay. Sorry. Here. Yeah. Okay. You see this one, tertiary carbon. Yeah. Okay. So okay, let me just quickly go through what is SN1. Okay. SN1 means that um you will lose the bromine first. Okay. You will lose the bromine first, and then you form this carbocation. Carbocation. Okay. And then the OH comes along and forms a bond. Okay. So this one is a two-step process. Two-step process. Okay. You form a carbocation intermediate. This is SN1. Okay. This is SN1. Okay. How about SN2? Okay. SN2 is, it happens at the same time. The bromine leaving and the OH coming, it happens at the same time. So it forms this transition state. Okay. Transition state. And then in the end, bromine is gone. The OH, okay, become the alcohol. Nucleophilic substitution. SN1 and SN2. Okay. So we are saying that this tertiary, tertiary carbon, it will prefer SN1. Okay. It will prefer SN1. Okay. So we want the bromine to leave first. We want it to go away first. Okay. Why? Because it's too crowded. Okay. It's too crowded. We cannot form this transition state. Okay. It's too crowded. So we want the Br to go away first, then the OH come along. So tertiary carbon, we will prefer SN1. Okay. And then this one is a primary carbon. Okay. Primary carbon. Only one carbon group attached to this center carbon. Okay. This one primary is not crowded. Okay. Not crowded. So it can form this transition state. Yeah, it can form this transition state. Both group at the same time. It can form this transition state. So this one, it will prefer SN2. Okay. So that's why we mentioned just now. Okay, this one, primary carbon will be SN2, tertiary carbon will be SN1. Okay, so we establish this information. Okay, time taken for this one. Okay, and then it will be T1. Okay, time taken for this one. This one will be T2. Okay, and then we want to know which one is faster. Okay, which one is faster? Okay, if we look at, excuse me, if we look at our notes, okay, yeah, um, okay, so we can see here, SN1 is always higher than SN2. Yeah, okay, SN1 is always higher than SN2. Okay, yeah. So we are saying that, uh, okay, this one will be faster. Okay, so means T2 will be shorter time. Okay, so this one is slower. Okay, so means T1 will be longer time. Okay, so T1 is longer time, so means we are saying T1 will be greater than T2. Okay, so we can check one by one. Okay, T1 greater than T2. Okay, so this is no. Okay, for the 1-chloro, the main mechanism is SN2. Okay, it's SN2. Okay, SN2. So this is no. Okay, the 2-bromo, the main mechanism. Okay, this 2-bromo, the main mechanism is SN1. Okay, SN1. Okay, So this is the one. Okay, that is the correct combination. Yeah, okay. This is the correct combination. So this is how we get the answer. Okay. Okay, 36. Okay, so this is a structure of progesterone. Okay. Which statement about progesterone is correct? Okay. So one molecule of the progesterone, it contains 4 chiral carbon or 6 chiral carbon. Okay, we can check that one first. Okay, so chiral carbon will be, okay, we want to check all 4 groups attached different. Okay, all 4 groups attached different. So it will be like this. Okay, so these are the carbons with all 4 groups different. Okay, yeah. Okay, so actually we have 1, 2, 3, 4, 5, 6. 6 chiral carbon. Okay, so means this one is wrong. Okay, 4 chiral carbon is wrong. Okay, 6 chiral carbon is correct. Okay, molecular formula is C19 or C21. Okay, let's check. C19 or C21. Okay, let's check. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. Uh, 21. Yeah, okay. So it should be 21. Okay, so 21 is the correct answer. Okay, hold on. Okay. Yep. So this is the correct answer. So our answer is D. Okay. Carry on. Okay, 37. Okay, a molecule of hexane can be cracked in a number of different ways. 3 compounds are listed. Okay, which compounds are found in the mixture of products from the cracking of hexane molecules? Okay, let's quickly take a look. Okay, the cracking process. Okay, cracking process. And yes, this one. Okay, cracking. Okay, so what is cracking? Okay, cracking means that, okay, we break down the long chain into shorter chain. Yeah, okay. We break down the long chain into shorter chain. So that is cracking. So we got 2 types. Okay, thermal cracking and catalytic cracking. Okay, thermal cracking, we heat with steam at 800 degrees Celsius. Okay, for catalytic cracking, we use this zeolite catalyst. Okay, zeolite catalyst. Okay, so both give a similar result. Okay, the main thing is it must give alkenes. Yeah, okay, it must give alkenes. Like this one is 18. Okay, it will give alkenes. Okay, and then this one also give the 18. Okay, and then yeah, so basically it will be break down into different chain length. Yeah, it can break down into like all the different chain length. Yeah, okay. So the key point is the carbon all combined together, we will get the same number of carbon. Yeah, so that's the main point. We'll get the same number of carbon. Yeah. So if we balance the equation, we just need to make sure we form the same number of carbon. But the key point is it will form alkene. Yeah, alkene or okay, longer alkene or shorter alkene like 18. Okay, so it will form alkene. So this is the main point. Coming back to our question here, okay, we have hexane. 1, 2, 3, 4, 5, 6. Okay, so one thing confirmed it will definitely form 18. Okay, it will definitely form 18. So it will be like this. Okay, the product, and then so this one will be 1, 2, 3, 4, something like that. Okay, so this one can be one of the products C4. This one is C2. Okay, so now okay, if we are saying that we have C3H8, is it possible or not? Yes. Okay, so if we break at here, we'll get a 3 carbon product, no problem. We can do it. Okay, C4H8, possible or not? Can. We break at the 4 carbon position. Okay, we get this. Okay, also no problem. Okay, C5H12. Okay, this one is not possible. Why? Because we minimum will form 118. Okay, we minimum will form 118. So the other one must be C4 and below. Okay, C4 and below. It cannot be C5. Yeah, okay, because we are forming minimum, the 18. So this one cannot be C5, C4 and below. So answer will be 1, 2. Yes, okay, 1 and 2 only. Okay, next. Diagram shows structure of two isomeric carboxylic acids, okay, X and Y. Okay, X can be reduced to compound P with empirical formula, okay, C2H5O. Okay. Okay, reduce to compound P with empirical formula C2H5O. Okay. Y can be reduced to compound Q, empirical formula C2H5O. Okay. So basically, we are um we are reducing this one. We can see the acid group. Okay, this is the acid group. Okay, so reduction, we are reducing the acid group. Okay, just now, I mentioned, okay, acid reduce, okay, to alcohol. It can happen. So we need a strong reducing agent, lithium aluminum hydride. Okay, so we need a strong reducing agent. No problem. Okay, so both can be reduced. So we can see that this is a cis isomer. Okay, so this is a trans isomer. Okay, so in the end, it will turn to alcohol. Okay, it will turn to alcohol. Okay, so now which statement is correct? Okay, X is a cis isomer. Yes. Okay, so this one will be incorrect. X is a trans isomer. Okay, compound P and Q, they are identical. Okay, no, they are not identical. Okay, so they will be the cis isomer and the trans isomer even after they reduce to OH. Yeah, okay. So P and Q, they will still be isomers of each other. Okay, so the answer is B. Okay, so we are just changing the OH group. Okay, okay, next. Okay, what is the total number of sp3 hybridized atomic orbitals used in the bonding of butene? Okay, so sp3 hybridization is uh C C single bond. Yeah, okay, single bond. So this is a sp3 hybridization. Okay, so the carbon, it forms a tetrahedral, okay, arrangement. So this is a sp3. Okay, um sp2 is when we have double bond. Okay, so when we have CC double bond will be sp2. Okay, okay, let's take a look. build 2 in. And hold on. Okay. Hold on. Okay. 1, 2, 3, 4. Okay, build 2 in here. Okay. So this one we have 3 hydrogen. Okay. 3 hydrogen. And then here, okay, 3 hydrogen. Okay. So this one is sp3. Okay. Hold on. Okay, sp3. Okay. 3, 1, 2, 3, 4. 4 sp3 orbitals. And then this one again. 1, 2, 3, 4. Okay. 4 sp3 orbitals. Okay. So total is 8. Okay. So that's our answer. Okay. How about the sp2? sp2 is like this. Okay. So we have the hydrogen here and then the hydrogen here. So the sp2 orbitals. Okay. So the sp3, the bond angle is 109.5. Okay. For the sp2, the bond angle is 120 degrees. Okay. So sp2 is 3 plus 3 equals to 6. sp2 is 6. sp3, 4 plus 4 is 8. Okay. Next. Okay. Okay, compound L contains carbon atoms. It is analyzed in a mass spectrometer. The table shows relative abundance of the only 2 peaks recorded with Me greater than 127. How many carbon atoms are present in one molecule of compound L? Okay, so this one we discussed before. This one is this topic here. Okay. Okay, this one. Yeah, okay. So when we have the mass spectrum, if we want to work out the number of carbon, okay, the number of carbon present in the molecule, we will use this formula. Yeah, okay. We'll use this formula. Okay. Hold on. Eh, yeah. Okay, we'll use this formula. So we have equal to 100 divided by 1.1. This one, AM plus 1, is the larger one, which is 5.5. Okay, this AM is the smaller one, which is 50. Okay, 5.5, 50. Okay, so if we calculate this, we will get 10. Okay, so from this formula, we can, this is another information we can get from the mass spectrometer. Based on this information, we can work out how many carbons are present in the molecule. Okay, so saying that this compound L is having 10 carbon. Okay, yeah. Okay, so this one is done. Okay, yeah. Hold on. Okay. One. Yep. Okay, so now we move on to the next paper. Okay, let's move on to the next paper. A this one. Okay, hold on. Okay. Um okay, so this one is also one of the recent papers. February, March 2025, paper 2, AS level structured questions. Okay. So yeah. So we have like some organic chemistry questions a bit here and there. Okay, there is one question that is fully organic chemistry. Okay, so we will look at that one only. Okay. Hold on. Okay, this one. Okay, question 4. Okay, so this one is fully organic chemistry. Okay, let's take a look. Okay, so we have compound J to M, each of which contain 4 carbon atoms. Okay, the table gives details tests on J to M. Each test, only 2 compounds give a positive result. Okay, let's check. Okay, yep. Hold on. Okay, hold on, let me do it again. Okay. Okay. Okay, let's take a look. Okay, so first one, acidified dichromate. Okay, so this one is for oxidation, right? Okay, so the purpose is oxidation. Okay, so which one it can oxidize? Okay, compounds that will give positive result. Okay, compounds that will give positive result. Okay, so we are saying that it is J and L. Okay, so J and L. Hold on. A wait. Oh, yes, yes, yes. Okay, this is aldehyde. Okay, aldehyde. Okay, this is alcohol. Okay, so both can be oxidized. The aldehyde, it can be oxidized to carboxylic acid. Okay, so it will be like this: 1, 2, 3, 4. Okay, 1, 2, 3, 4. COOH. Okay, so it will turn to COOH. Okay, alcohol, secondary alcohol, it will oxidize to ketone. Yeah, okay. So it will oxidize to ketone. Yes. So this one, ketone, it cannot oxidize anymore. This one, carboxylic acid, cannot oxidize anymore. So it will be J and L. Okay, observation of the result. Acidified dichromate, there will be a color change. Okay, when the oxidation reaction happens, there will be a color change. So the dichromate will change from orange to green. Okay, so we expect to see color change from orange to green. Okay, next. Okay, 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 next group. Okay, alkaline I2. Okay, alkaline I2. Excuse me. Okay, so this one is the triiodomethane test. Okay, we know that you can get a yellow precipitate. So this is test for what? Test for the methyl ketone. Okay, or okay, it tests for 2 things. Okay, okay, methyl ketone. This one. Okay, another thing it tests for is the carbon is OH, H, and CH3. Okay, this group. Okay, now we check. Okay, methyl ketone. Yeah, okay. So this is a methyl ketone. And then this one. Okay, carbon joined to hydrogen OH and another metal group. Okay, so our answer will be K and L. Okay, our answer will be K and L. Okay, next. Okay, orange precipitate. Okay, orange precipitate. Uh, which one will give orange precipitate? J and K. J and K. Okay, so this one is aldehyde. Okay, this one is ketone. Okay, so just now we mentioned before, the one that give the orange precipitate is 2-DNPH. Okay, this 2-DNPH test, it is positive for both aldehyde and ketone. Okay, as long as it is the carbonyl group, it will give a positive result. Okay, so the test is 2-DNPH. Okay. Next, okay, sodium. Okay, sodium. Just now, um, we mentioned. Okay, so sodium, it can react with both alcohol and also acid. Yeah, okay. So it can react with both alcohol and acid. So it will be this one, alcohol and acid. Okay, Ln. Okay, so our answer will be Ln. Okay, how about our observation? Our observation, okay, as mentioned before, a it will produce hydrogen gas. Okay, metal plus alcohol or metal plus acid, it will produce hydrogen gas. So we expect to see effervescence. Yeah, okay. So for the hydrogen gas. Okay, so that's the idea. Okay, next. Okay, K. Okay, K here. Okay, so we can see that this is a ketone. Okay, so ketone react with HCN. Okay, so we know this is a, just now we discussed, nucleophilic, okay, addition, right? Because we have the delta positive, delta negative, okay, on the CO. So the delta positive will attract the nucleophile. Yeah, okay. So it will attract the nucleophile. Okay, let me quickly show the notes. Hold on. Okay. Yes. Okay. So nucleophilic addition. Okay. So how it happened? So we need to, what we are asked to do, we are asked to draw the mechanism. Yeah. Okay. So we are asked to draw the mechanism. So we need to memorize this part. Okay. So how it happened? The nucleophile comes along, attack the delta positive carbon, and then at the same time, this pair of electrons go to the oxygen. Okay, so we get this situation here. So now the nucleophile already connected. Okay, and then the oxygen, it becomes negatively charged. And then after that, okay, the hydrogen comes along and then attach. So we get the final product. Okay, so this is our final product, nucleophilic addition. Okay, so our question, okay, what we need to include in our answer. Okay, complete figure 4.2, okay, to show the mechanism for this reaction. Include charges, dipoles, lone pairs of electron, and curly arrows as appropriate. Okay, so what we expect to do is like this. Okay, so now, okay, the nucleophile comes along, okay, attack, okay, and then the negative, one pair of electron goes to the oxygen. So now we have this negative charge on the oxygen, okay, react with the H plus, okay. So in the end, we get the final product, okay. So we need to memorize this mechanism, okay, memorize this mechanism. Okay, Next, identify the class of compound N, which is a member. Okay. The class of compound, which N is a member. Okay. So what is this functional group? We have the OH and the CN. Okay, this is called hydroxynitrile. Okay, so this functional group is hydroxynitrile. Okay, next, N has a chiral center. Okay, so we can see that this is a chiral center. Okay, so this carbon has 4 different groups attached to it. Okay, so this is a chiral center. Explain what is meant by chiral center. Okay, so this is straightforward. Okay, atom or carbon with 4 different atoms or functional groups attached to it. Okay, straightforward. Okay, and then it's done. Okay, it's done. Okay, this is done. Okay, so we still have time. Let's move on to the next paper. Okay. Okay, next paper. Okay. Okay. May, June 2025. Okay, one of the recent papers, May, June 2025, paper 1, multiple choice. Suppose, okay, we should be starting from question 25. Okay. Um, okay. Okay, we should be starting question 25. Okay, let me check. Um, okay, yes, question 25. Okay, 3 reagents are listed. Okay, aqueous sodium carbonate, lithium aluminum hydride, and water. Which reagent react with pure ethanoic acid? Okay, pure ethanoic acid. To give a solution containing ethanoic ions. Ethanoic ions. Okay, so ethanoic acid. Okay, plus lithium aluminum hydride. So this one is reduction. Okay, so reduction, we will get alcohol. Yeah, so we'll get alcohol. So suppose we do not get. Okay, um we do not get, okay, ethanoic ions. Okay, so no. Okay, aqueous sodium carbonate. Okay, so sodium carbonate is alkaline. Okay, alkaline plus acid. Okay, so this is neutralization. Neutralization. Okay, let me show. Okay, um okay. Yes, here. Okay, reaction with sodium carbonate. Okay, carboxylic acid with sodium carbonate, it will give us this. Okay, so this is ethanoic acid. Ethanoic acid. So this one is the ethanoic ion. Yeah, so this is the ethanoic ion. Okay, with the sodium, which forms the salts, and then form carbon dioxide and water. Okay, so our answer is this. Okay, so we need aqueous sodium carbonate and we need water. Okay, so the answer is 1 and 3. Okay, for this neutralization to happen, so it will give us the ethanoic ion. Okay, next. Okay, question 26. Okay, complete combustion of compound T produces carbon dioxide and water only. Okay, no problem. So means it is a organic. Okay, organic compound. Okay, compound T produces steamy fumes with PCl5. Okay, so just now we mentioned before. Okay, um, steamy fumes with PCl5 is um, alcohol. Okay, alcohol substitution. Okay, something like this. Alcohol substitution to halogenal alkene. Okay, so okay, compound T does not give any visible product with this 2,4-DNPH. Okay, so this is a test for aldehyde. Okay, aldehyde and ketone. Okay, yeah. So if this one um uh no reaction, this one no reaction, which means this is not aldehyde. Yeah, okay. So it's not aldehyde. So this part we can confirm. Okay, this part we can confirm. Okay, compound T is a carboxylic acid. Okay, so this one we cannot really confirm. Okay, so this part we cannot really confirm. Okay, let me check quickly. Hold on. Okay. Okay, so this part we cannot confirm for the PCl5. Okay, so for carboxylic acid, okay, um, so carboxylic acid is no reaction with PCl5. Okay, so hydrocarbon also no reaction with PCl5. Okay, um, yeah, okay, so this one 2-DNPH. Let me confirm one more thing. Um, okay, okay. Okay, most important condensation, carbonyl compounds that can react with the 2-DNPH. Okay, so it is a test for the carbonyl compounds. Okay, so for this particular question, what we can confirm is it is definitely not aldehyde. Definitely not aldehyde. So the rest we cannot confirm 100%. Yeah, we cannot confirm 100%, even for the alcohol part, because there may be other groups, okay? Other groups that can react with the PCl5. Yeah, okay. Let me quickly confirm. Okay, hold on. Okay. Hold on. Okay, reaction of alkenes. Um, Yeah, so anyway, for this particular question, our main point is not aldehyde. Yeah, okay. So this is the um clear answer there. Okay. So the rest we cannot confirm 100%. Okay. So we just can say that it's not aldehyde. Okay. Next, 27. Okay, information about carbonyl compound X is given. Okay, so carbonyl reacts with lithium aluminum hydride to produce secondary alcohol. Okay, so which means it must be a ketone. Yeah, okay. So ketone can reduce to secondary alcohol. Okay, so okay, so means this aldehyde is no, aldehyde is no. Okay, and then compound X react with um alkaline I2 to give a yellow precipitate. So this one is the metal ketone. Okay, metal ketone test. So which one has a metal ketone? 1, 2, 3, 4. Okay, and then this one. 1, 2, 3, 4, 5. Okay. Yep. Okay. So the one with the metal ketone is this one. Yeah, okay. So this one no metal ketone. So our answer is B. Okay. All right, next. Okay. Organic compound J reacts with excess of sodium to produce organic ion with a charge of -3. Okay, react with excess sodium hydroxide to produce an organic ion with a charge of -1. Okay, okay, so this one it react with both um okay react with both sodium and sodium hydroxide. Okay, so as I mentioned before, just now, if we have alcohol, it can react sodium only. Okay, acid, it can react both sodium and sodium hydroxide. Okay, because it is a stronger acid. Okay, now react with sodium to produce a charge of -3. Okay, so which means it can be both. Okay, react with sodium. So it can be acid or alcohol. Okay, either group acceptable. Okay, so we can see here, this one, alcohol. Okay, let's see. Okay, okay, okay. So this one, alcohol, alcohol, acid. Okay, this one, acid, alcohol, aldehyde. Okay, um, this one, acid, alcohol, acid. Okay, this one, um, alcohol. This is ketone. This is aldehyde. Okay, so now we will eliminate this one. We'll eliminate this one because aldehyde and ketone, they do not react. They do not react with sodium and sodium hydroxide. No reaction there. Okay, so we eliminate these two. Okay, so now we are left with these two. Okay, we are our answer is actually A. Okay, so we will look at C first. Okay, why C is wrong. Okay, let's check. Okay, react with sodium. Okay, so this one can react with sodium. This one can react with sodium. This one can react with sodium. No problem. Okay. React with sodium hydroxide to produce -1. Okay. -1 means only one group reacted. Only one group reacted. But this one, we got two acid group. We got two acid group. It should be -2, not -1. So this is wrong. Okay. So that's why we say this is wrong. Okay. Let's check A. Why A is correct. Okay. React with sodium. Okay. This one can react with sodium. This one can react with sodium. This one can react with sodium. -3. Okay. No problem. Okay. React with sodium hydroxide, -1. Okay. -1, sodium hydroxide, only acid can react. So we can see we have one acid here. Only acid can react, one acid group, so we get -1 charge. No problem. Okay? Excuse me. So that's the idea. Okay? So how the reaction happen? How the reaction happen? They lose. Okay, the COOH, they lose the hydrogen to form this. Yeah, so that's why we have the -1 charge there. Okay? And then the OH, okay, it lost the hydrogen. So we get like this. Okay, so this is another one, the negative charge there. Okay, so that's the idea. Okay, 29. Okay, which formula represent the organic compound formed by the reaction of propanoic acid with methanol in the presence of concentrated sulfuric acid as a catalyst? Okay, so what kind of reaction is this? So this is a um uh ester. Okay, ester formation. Okay, ester formation. Okay, let's check. Um, okay. So, okay, how we form the ester? This one. Okay, okay. So alcohol with acid, okay, will form the ester. Okay. So, reaction condition, carboxylic and alcohol, okay, with concentrated sulfuric acid, reflux for 4 hours. Okay. So another reaction condition, carboxylic acid and alcohol, dry hydrogen chloride. Okay. So two reaction conditions. So concentrated sulfuric acid is for formation of ester. Okay. So now we have the propanoic acid, 1, 2, 3, COOH plus methanol. Okay, like this. Okay. So what we will form is like this. Okay. 1, 2, okay, and then the ester bond like this. And the the last carbon, okay, the last carbon. So this part will be CH2, this part will be CH3, okay. So now which one fulfill our condition? Okay, so this one, okay, CH3, CH2, COO, CH3, CH2, COO, and then finally another CH3. Yeah, okay. So that's the idea. Okay. Yep. So the answer will be B. Okay. Yeah. Okay. So this is 3 carbon. This is 1 carbon. Okay. So total 4 carbon. So you see this one, 1, 2, 3, 4, 5. 5 carbon. So this definitely wrong. Okay. So this 1, 2, 3, 4. This is only 1 oxygen. This is also wrong. Okay. And then this one is 2 carbon, 2 carbon is wrong. So because we have 3 carbon plus 1 carbon. Okay. So the answer is B. Okay. Okay, next. Okay. Yep. So this is quite a tricky question. Let's take a look. Okay. So structural isomerism and stereoisomerism should be considered when answering this question. Okay. So we have a molecule 2,4-dibromohexane heated under reflux with ethanolic potassium hydroxide. Okay. So what kind of reaction is this? Okay. Is this one? Hold on. Okay, this one. Yeah. Okay, this one is bromoalkane. It turns to the double bond. Okay, so it's this reaction here. B5. Yep. Yeah, here. Okay. Potassium hydroxide or sodium hydroxide in ethanol plus heat. Okay. So this reaction is the elimination reaction. Okay. Elimination reaction. So basically we have Br. Okay. It's elimination. It turned to the alkene. Yeah. Okay. So it is an elimination reaction. Okay. So now coming back to our question. Okay. So what does our molecule looks like? 2,5-dibromohexane. Okay. 1, 2, 3, 4, 5, 6. Okay. Bromo at the second and the fifth carbon. Okay. Like this. Okay. How many isomeric compounds are formed with the molecular formula of C6H10? Okay. So what actually happened? We have elimination. Yeah. Okay. So we have elimination that happened. Yeah. Okay. We have elimination that happened. Okay. So the elimination can happen in so many ways. Okay. So it can happen. Okay, let me show. Like we can eliminate these two. Okay. But I can also eliminate these two. Okay. So this is also possible. Okay. And I can also eliminate like this. Okay. Okay. I can also eliminate like this. Okay. So many ways it can happen. Okay. So we need to go through one by one. Okay. Um, how many alkenes we can get? Okay. So this is the alkene product. Okay. So we start with the bromo. Okay, it turns to the alkene. Okay, but this is more complicated. Okay, so what are the different possible variations? Okay, so we go through one by one. Okay, so first one, we eliminate like this, and like this. First one. Okay, so we will get like this 1, 2, 3, 4, 5, 6, like this. Okay, so this is the first answer. Okay, secondly, we can eliminate like this. Um, like this. Okay, so like this, we will get 1, 2, 3, 4, 5, 6. Like this. Okay, and then the next one, okay, so this one is we have two double bond. Okay, this one there is no cis trans. Okay, so this one has no cis trans isomerism because this one same group, hydrogen and hydrogen. Okay, so this one no cis trans isomerism. Okay. But this one, it can have cis trans. This one it can have. So this one is the trans. Okay. So this one trans, this one trans. This is trans. Okay. So we can have the cis situation, what it looks like. Okay. Wait. Hold on. Okay. Uh, okay, like this. Okay, so this is the cis situation. This is cis, this is cis. Okay, and then we can have the this situation like this. Okay, okay, and then okay, like this. Okay, so you can see this is cis, this is trans. Okay, so this is the cis trans situation. Okay. And then next, well, what else can we have? Okay, now we can eliminate this one and this one. Okay, we can eliminate like this. Okay, so that will give us this um like this. Okay, so this one is no cis trans isomerism because hydrogen. Okay, so this one don't have. Okay, okay, but we can see that this is a trans. Okay, so we can have the cis variation. Okay, like this. Okay, so this is the cis. Okay, so in total, we have how many possible isomer? Okay, 1, 2, 3, 4, 5, 6. Okay, yeah, so our answer is C. Okay, in the exam situation, it may be a little bit difficult to work out all of them. Okay, you just try your best. Okay, you just try your best. Okay, question 31. Okay. Uh, question 31. Okay, next. Okay, considering only structural isomers, what is the number of alcohols each type with the formula C5H12O? Okay, C5H12O. Okay, how many primary alcohol we can make it? C5H12O. Okay, how many secondary alcohol? How many tertiary alcohol? Okay, so we try our best. Okay, primary alcohol, we can have like this. 1, 2, 3, 4, 5. And then OH. Okay, primary alcohol. Okay, all like this. 1, 2, 3, 4. OH. And then like this. Okay. And then 1, 2, 3, 4. OH. And like this. Okay. And okay. 1, 2, 3. Okay. And then like this. Okay, 1, 2, 3, 4, 5. 5 carbon. Okay, so we can have 4 primary. Okay, alcohols. Okay, secondary alcohol. Okay, 1, 2, 3, 4. Okay, like this, and then like this. Okay, so this is a secondary alcohol. Okay, the next variation. 1, 2, 3, 4, 5. Okay, and then we like this. Okay, secondary alcohol. Okay, another one. Okay, Okay, 1, 2, 3, 4, 5. Okay, so this is also secondary alcohol. Okay, secondary, secondary, secondary. Okay, so this is a primary, 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 primary. Okay, so the carbon only attached to one other carbon. Okay, you see? Uh, yeah, so this one is primary, primary. Okay, how about tertiary? Okay, um, like this. Okay, so this is a tertiary. 1, 2, 3, 4, 5. Yeah, okay. So this is a tertiary carbon. So our answer is 4, 3, 1. Yeah, 4, 3, 1. Okay, so this is our answer. Okay, yep. So it's almost time. I think we can stop here. Okay, so next time we can continue same kind of thing, or if you want to do something else, you just let me know. Okay, so otherwise we will continue on the organic chemistry. Paper 1, paper 2, we just keep going on the organic chemistry. And then the next class will be next Thursday, same time. No problem. Huh? Okay, next Thursday, same time, yeah?
Yeah, I think it's Thursday, next Thursday.
Okay, next Thursday, same time. But if you want to change the time, you just let me know. Okay, and I will just continue to prepare more organic chemistry problems. Okay, just more organic chemistry past exam papers. So we just continue with this. But if you want to like change to other topics, you just let me know. Okay, then
Okay.
then we can do that. Okay, so if no other question, we will stop here. See you next week. Okay,
Thank
same
you.
time. Okay, thank you, thank you. Bye bye.